My name is Daniel McKinney. This is my 7th grade life science class, and we are here at Holman Middle School. Today we're going to be talking about how humans interact with the environment and how those interactions can cause both good and bad effects. All right, everybody, what I would like for you to do is to get into today's Schoology page for me. And you're going to want to find climate change in our oceans. If you want to look at my screen, just to know exactly what it is you're looking for. And I see that Xavier has accessed it. So you're going to see climate change in our oceans. You should see a picture of SpongeBob and Squidward. Not Squidward, Patrick. That's a cardinal sin. That's Patrick. And then I want you to scroll down to where it says Part 1 Investigation. So scroll to Part 1 Investigation. And then once you have done that successfully, I would like you to 45 your screen for me, because that will let me know you're where you need to be and we're ready to roll. I'm going to hold on a hot second for my last few people to do what it is they need to do. Excellent. So to start with today, I want to pick up with basically what we left off with last time. We did a gizmo activity, and what was it that we were trying to see affecting the water? That's okay. The farms. Okay, we're just picking up where we left off. I know not everybody finished it. We're going to actually finish that part up today. The farms. What were the farms doing?
They were overusing the manure and stuff, and then it got to the water.
Okay, so there was manure getting released into the water, the pond water. And then the other part of that is, what else is washing from the farms into the pond water?
Animal waste.
Animal waste we got.
Oh.
What nutrient is coming along with that animal waste as well as some other things? Fertilizer. And what is in fertilizer and what is in the manure that's getting into the pond and throwing things off? All right, go ahead, Madav.
Nitrogen.
Nitrogen. So we looked at that, and then remember with the bottle, we saw that what dissolves in water?
Nitrogen.
Not nitrogen, but a solid liquid or gas.
Gas.
Gas is dissolved in water. And what gas in the farm water was really low when we added a lot of farms?
Oxygen.
The oxygen. And so that caused a bad environment for what type of organism to survive. And we saw that through what happened with the gizmo. What did we see?
It was a lot harder for the fish to live there.
Why? Why did they not thrive as well? Because the numbers went down, right? I think when I did it, I had like 5 catfish and maybe 1 or 2 trout, and then it went down to 0 for me. Why did that number change so much? What did the fish, or let me ask it better, what did the fish not have that they needed in order to be successful?
Clean air.
Where was the air though?
Clean water.
In the water. So they needed the gas. So what gas in particular did they need to survive and thrive? Not carbon dioxide. That would be for the plant potentially. They needed oxygen. And so in that example, human behavior impacted those levels. What we're going to look at today, if you look at my 3 questions, we're going to look at the nutrient cycle still, and we're going to look at how humans are impacting the carbon cycle. How does human behavior impact the level of carbon dioxide, and what effect does that have? And we're going to do that by collecting data and observations to try to see how human behavior is impacting our environment. If you will look at my screen up front, you don't need to open yours because it's the same thing. We're going to look at that with our oceans. The oceans are actually a place where you can really see the effects of increased carbon dioxide and with it global warming. So I'm going to do a demonstration, and then y'all are going to use what you see in the demonstration to help answer some evidence for the claim. And then you are going to independently in your groups look at some more pieces of evidence and come up with kind of a collective understanding. How do humans impact it? You'll look to see how we're negatively impacting it. And there are also some ideas that scientists are coming up with to try to combat climate change that you may not have seen before. So that is the goal and the mission of what we're doing right now. So what I would like for you to do is to spin around and look at me at the back. I'm going to do a quick little demonstration here.
You want to pop it?
Maybe. We'll see. And then I'll explain what all it is that I have and how I'm using it. Okay. What's in this?
Helium.
Air. It's not helium, but that's a good guess. That is a type of gas, okay? And this is just basically me blowing into the balloon, which is probably going to be a lot of what gas? Carbon dioxide. Will it be all carbon dioxide? What else is really abundant in our air and atmosphere? Nitrogen, one of the most abundant, and also some what that I didn't use in my lungs? Some oxygen, right? We can't use all of it. So that's going to be in this balloon. And then in this balloon, I've got water, okay? All right, so this is just air, obviously. This I want you to think of as the ocean, okay? This is the ocean that is in this balloon. What we're going to do is we're going to apply some heat. Now you could do this in a couple of different ways. If you had a really bright hot light, you could use it to demonstrate the heat. I'm going to use a lighter for this to demonstrate the heat, okay? Obviously, should y'all do this at home on your own? No? Okay. Do not. Do not. I want to throw that disclaimer out there. Okay. So, I'm going to do it with each one, and we're going to see what happens. Do you think one of them is going to pop?
Yes.
Raise your hand if you think this one's going to pop. All right. Raise your hand if you think this one's going to pop. Raise your hand if you think they're both going to pop. Raise your hand if you're hoping this one pops so I get soaking wet. I would, at your position, I would have too. All right, so let's see what happens here. If you are somebody that doesn't like loud noises, if you want to plug your ears, that might be advisable because one of these may pop, okay? All right, so let's see. I'll let you get set up in. Go ahead. All right, you ready?
Ready?
All right. So let's see what happens. Okay. Obviously, did that work out?
Not really.
Maybe. It might prove my point, but was it able to last?
No.
No. All right. See what happens with this. So again, what are we symbolizing with this? Symbolizing the ocean, right? All right, let's see what happens with this. And I'm at the same distance as it. All right. And the flame does touch it at least once. So you see the black marks? So I'm putting the flame on it.
Just pop it.
But obviously something's happened. I know you're rooting for that. I understand. All right, clearly something different's happening, isn't it? All right.
The water's strong.
That sounds like a great idea that you're getting ready to share with your group. So here's what I want you all to do. And look up at this front, and then you'll open your screens once I'm finished. The claim is that the ocean has a significant, meaning an important role or job in maintaining Earth's temperature. How does my demonstration show that that claim is true? Come up with 2 reasons.
Water cold.
Type it in there. Type your ideas in there. Put what you think.
Water cold.
Why does my demonstration show that that is a true statement? So put it in there. What do you think the demonstration shows? What does it show?
Because the water is always so cold, because it was just winter and the coldness is still in the water. So usually I go towards the end of the year to where most of the water's had
So
time
the
to
water
warm
can
up.
take more heat. And I picked up the balloon to see if there was any evidence for you all, but it just looks like a shredded balloon to me. So here is the balloon that didn't pop. I'll walk it around to you.
Touch it. It's not too hot anymore.
I wanted to prove to you that I did put the flame on it. I didn't cheat. So if you want to just look at it for evidence, maybe it'll give you some more idea. You think so, huh? I don't know if I'm quite that high budget. Not quite. So that's where the flame hit it. So you can give me evidence from the balloon that popped, or you can give me evidence from the balloon that did not pop. So whatever one you want to use, what evidence do you have that shows that oceans have a significant role in maintaining Earth's temperature? What evidence do we have? What of?
Water takes a lot longer than air to heat up.
So the water takes more time than the air to heat up. So you think that had an impact on the balloon not popping. Now, where was the heat hitting on this balloon?
The rubber.
It was hitting on the rubber, correct? So you said, and say what you said again, because I want to just make sure I don't rephrase it for you.
It takes a very long time to heat up.
It takes a long time to heat up. Raise your hand if you had something similar as to why you think that's why this one did not pop. So I think that is a part of our answer. What is another piece of evidence? Because I don't want to give it away. I want to see what you all thought. Cooper?
In the one with the air, the balloon was kind of like bigger, so the rubber was more stretched out.
So the rubber is stretched out more, which is going to make that rubber what?
Thinner.
More thin. So if I were to do this again, it may be helpful to measure out the air and the water to make sure that they are equal. Now the shapes may be different, because to get the same amounts it could, to stretch it out, that might take it. But that is something that could improve it and make sure our accuracy is there, right? Great observation. What else do we notice about the evidence? Xavier?
Maybe it could be because when I touched it, the water was cool. It could be that the water is just cooling down the balloon before it can get hot enough to melt.
So the water is keeping the rubber cool enough so that it does not melt. Okay. So obviously the difference here is the rubber on this one stayed together, but the rubber on the other one did not. So the water is the difference for the cooling. Let's apply that to the ocean then. What does that tell us about our oceans? If that's true for this, what is it showing about the oceans? Go ahead, Ashley.
Water can keep fire from not getting really big.
Keep fire from getting real big?
No, yeah, wait.
Okay. All right. What is the ocean doing for us on Earth? What is it helping to do?
Cool it down.
Possibly cool it down.
Give the ocean animals a home.
Yes, it's giving them a home. It's maintaining a temperature. It's helping to keep a temperature the same, because water takes a long time to either what or what? Heat or cool down. I'll give you an example. Why is Memorial Day such a tough time at a pool? Well, it's hot outside. I agree with that.
It's crowded.
It's crowded. Yeah, y'all getting the right ones on that part. What about the water temperature?
It's
Probably
cold.
It's cold. It's really, really cold, because it hasn't had enough time to do what? To heat up. How long? Anybody go to the pool over the summer? Anybody do that as a thing? How long does it take before the water's so nice that you don't even think about jumping in? I think June-ish July, right? Because it helps to maintain that temperature. So what I had up here, and this is very close to what you all said, the balloon with the air popped since the rubber melted because it got hot instantly. The balloon with the water didn't pop because the water is distributing that heat. So with the carbon cycle, what is a bad thing for our ocean to be doing then in terms of temperature? What are we not wanting to happen?
Being hot.
We don't want it to heat up, because if it is heating up, and by the way, the heat, what would that represent? What energy is it absorbing?
Sun.
It's absorbing the sunlight. So if the ocean is already warmer than it's supposed to be, that means that it will allow the Earth to get what?
warmer.
To get warmer than it needs to get. So the carbon is allowing for this heat to get trapped, which is making the oceans warmer, which means that more of the sun's energy gets trapped and it gets warmer. So it's cycling together and putting that together. Here's what you all are going to do. On this paper, or digital paper I should say, you've got a couple of data points that you're going to use to keep seeing how climate change is affecting the oceans. So you're going to look at A graph, you're going to look at a couple of videos. One of them is with Bill Nye. Another one of them is with an observation of how ocean acidity is rising. And then you're going to use that in an article to kind of put together all the effects that are happening to our ocean. Because when we wrap that up, it'll basically kind of summarize how humans are impacting the carbon cycle. So are there any questions about what it is you're doing?
No.
Okay, everybody good? All right, well, let's make it happen. Make sure that you're looking at the actual experiment. So what I think is really interesting about this is that if you look at the amount of actual acid that she puts in it, it's wild the effect that you get.
Okay, somebody.
So you'll see that once it starts going. So obviously, what's the chart show?
It shows the carbon, it shows the parts.
So what's that going to do to the ocean temperature?
It's going to make it rise.
So it's increasing that blanket around the Earth because it's holding in that heat.
Does the blanket also protect us from the sun?
It does. You want that kind of Goldilocks sweet spot, right? You want a little bit of that heat so that it keeps things happy, but if you get it overheated, then it creates issues. So you're exactly right. You want that sweet spot. Exactly right. What did she add to the cup?
Baking soda.
And
Vinegar.
vinegar. So that was a chemical reaction, right? What chemical do you think we would be interested in when you add that vinegar and baking soda? What gas is probably being released? Carbon dioxide. So when that carbon dioxide starts to hit the water, what does that water do? What did it do?
It absorbs. No.
Yes, it did.
Oh.
You're exactly right. It absorbed it.
It
and
turned
then
ugly.
it turned what color?
Yellow.
It turned yellowish, right? Now, there was a BT Bartholomew blue solution that helps you to see the change, which is why it turned yellow on it, okay? So when it turned a little bit yellow, it shows that it absorbed carbon dioxide and it turned more acidic. So the claims for climate change has a significant effect on our oceans. What did that first little experiment that you watched show you? What did you see happen in that experiment, and what does it tell us about the effect of climate change on our ocean? Hey, Ashley?
You saw the carbon dioxide because it was something of a blue can of what made it be seen because of vinegar and baking soda.
Yes. So when the vinegar and the baking soda get added to the situation, then carbon dioxide gas is created, and they placed what on top of the seal? A lid to kind of hold the gas, right? Did the solution of baking soda and vinegar hit the water?
Yes.
So I guess what I'm asking is, did the person mix those two things and dump it in the water? No. They didn't dump it in the water, and we know that because where's the placement of the paper cup?
Above the water.
It's above it. So it was not that the solids touched the water, it's that the vinegar and the baking soda turned into a gas. What happened to that gas when that occurred?
It dissolved into the water.
How do you know that?
Because it changed in color.
It changed the color. What did it change the color to?
Yellow.
It changed it to yellow. Did anybody pick up on what BTB solution shows? It's an indicator, which means that it helps you by color see what is or is not in the water. Did anyone pick up on that?
Maybe the pH.
pH, which deals with
Acidity.
whether it has a lot of acid in it or whether it is basic. A healthy ocean is typically 8.2 on the scale, and you really haven't necessarily done pH yet, but that's basic. But if it goes lower, it becomes more acidic. So that carbon dioxide dissolved into the water, and where is a lot of that carbon dioxide coming from? It's going into the ocean, you're right. Who's producing a lot of that carbon dioxide?
Us.
Humans are.
We kill everything.
How, we are a little rough on our environment, I would agree. What's the number one contributor that we are doing daily that's adding to that carbon dioxide?
Breathing.
Driving and fossil fuels, right? Breathing and respiration, you're right, that does add some to it. But the excess or the extra carbon that we're getting into it, it is really from the exhaust or other types of fossil fuels that we are burning. And then what impact if Ashley, what are you saying?
No, cars.
Okay. So if we lower the acidity, if we raise the acidity and it lowers the pH level, what possible impact is that going to have on the ocean?
A negative,
How?
because it would kill the marine life.
It could possibly kill living things. It could possibly kill wildlife or marine wildlife. So again, this is another impact of how we're seeing that carbon and climate change are impacting the health of our oceans. Thank you so much for joining us today for our lesson on carbon and human impact on the carbon cycle and our ocean health.
Go
Go Huskies!